Okay, so hey everyone, this is the review session for your midterm 2 that's happening tomorrow and the day after. I'm going to be going over the practice test 2 that's already up on your Canvas page. We'll be looking at questions that involve the use of our studio first, and then we can answer questions um, that do not require us. So let's go to the fourth question. I believe that's the one that we use first R on. So it asks you to load the dataset geog.csv. Contains a closing stock price for Google on the first day of each month from 2015 January till December 2016. Um, they want you to build a time series object and an autoregressive model using a lag of 1 month. And they're asking you for the equation of the resulting model. So let's go ahead and see how that can be done in R. Um, of course, the first line of command that you see over there, that can be used to remove everything that's already there on your working environment. I'm not going to be doing that, but I will import the raw data. You can see that the data is present at the top of your test, all the three data sets that you'll be needing for this test. Go ahead and download it and set your working directories to the place where it's downloaded so that you can work on it. So that's what I'm doing here. I'm importing the data, naming it as raw data, running that. So now it will be there in my global environment. Now what I'm doing is, so if I look at this raw data, let me view raw data for you. So this is what it looks like, right? I have a column for month and I want to build a time series object. Um, and I just want to consider the column stock price. All right. So I'm naming it as price and I'm creating an object called obviously called price, and the function to create a time series is ts, and I'm specifying that I want the column geog close from raw data. So that's how I create a time series object. You go and view this. It looks something like this. And now the question wants me to create an autoregressive model using the first lag. So I want to predict price based on the first lag of price. So I can go ahead and calculate the lag for my price variable. Um, Already created, and give k equals -1. That'll give me the first lag. Yes. Uh-huh. Okay, yeah, so I can do it. So for this, so that, because if I have raw data and I don't have the month or the year column in it, then I'll need to use the frequency. I'm saying that if you have just one column of data with but again, having the time series object and creating a frequency of 12, it's just for your own reference. At the end of the day, if you create a lag of -1, it's going to be offsetting it by a month and so on, right? So that's what that looks like. And I create the first lag with k equals -1. And what I do next is I want to run a regression to predict using price L1. But if you observe I can only use one data. I can only reference one data set inside my LM statement. So I need to bring in the price variable and the lag price variables into a single data set. And that's what the new data line on line 8, that's what the column bind command does. So it binds my price against price 1. And if I just print this out, you can see what it's done here. It's put them into columns near each other. So it's just one data frame now that has both the variables that I need for my regression. Questions? Okay. So next I'll go ahead and build a model using the LM statement. Using the first lag of price. Data equals new data because that's my data frame that has both the variables now. And print the summary of the model. There you go. So you get the estimate and one of the options on your test should be this one. Questions? So remember, three things you have to do when you're asked to build an autoregressive model. First, you create a time series object. It's simpler if you just create the time series object for the column that you want and not unnecessarily create it for every other column. Just do that. And then you uh, see with one by one. So read the question and see how many lakhs they're asking for and evaluate the model based on that. And yes, now you bind all of them into a single data using the feedback function, and then use the right. Everyone hear me over there? Okay. All right. So that is question 4. Go to the next question. It's question 5. It says for the data set and the model in the previous question, using the model for price against price L1, what is the predicted price for the next month, round to the nearest penny? Okay, so you have the regression result from here, and it tells me that 53.8532 is my intercept. Month, if they ask you for next month, that means the point where plus 1 month, which would be January of 2017, for which you need to look at the last data point that you have. So when I printed this variable over here, the last data point that I had is 115.4. So using that as your X values, you can calculate the new value as that. It would be 115.47 times 51.5123 plus 53.85 something. Yeah, 32. So that gives me a value of 113.0085, which would be my prediction for the next month. Any questions? Yes. Check for that. Okay, let me try that. Oh, not sure. What's the syntax for when you have to create a list inside of predict? Is that it? Hope that gives an answer. hmm Um, should be all the R problems, yes. Oh yeah. Anyway, so if you actually go to your previous homework, there should be the predict.lm statement and how to use it. So you can look at the syntax over there. I don't remember it right. Yeah. Okay. So yes, you have a question? That is correct. Okay, so that's what the fifth question was about. And then we're going to the next question. Same data set. He wants you to find the simple moving average of length 5 for the next value to the nearest penny. So that is the library in R that has the function MA. So you can go ahead and install the package forecast if you haven't already. I have in my computer. So I'll just run library forecast. And then I create an object called average. Uh, so enter center equals false. Concept where you sort of find like average, which is not make sure you and if you calculate that and print it out, that should give you the last value of that should give you prediction, which is 116.54. Questions? Yes, I can't hear you. Okay. The next question is the golf data set. It's called train.puts. And he wants you to build a logistic regression model predicting made against length. And he's asking you for the probability that a golfer sinks a 7-foot putt around to 4 places of decimals. So um, get that data in. It's called train. What's there on your test? Okay. And I create a model. So this is a generalized linear model. Okay, so if I run that now, and so obviously, what is the he wants you to he wants to know what the probability that a golfer sinks a 7 foot putt, and for that, first I calculate the log odds, then do the exponential transform. Right? Two ways of doing that: either use type equals response right over here. So adding type equals response would so yes. Uh-huh. Sum equals a binomial will take care of the same thing. Yes. I think they all do the same thing. So if you have family equal to binomial, that should be sufficient. This gives you the direct probability without the log odds. And if you ignore that type equals response, it's going to give you the log odds. Question? Yeah. So so you create a list over here. And hey, to answer your question, guy over there is not thinking at me now. That's how you use the predict statement. Okay, that's how you use the predict statement and specify the new data inside of it, right? List of length equals. And to answer your question, you just type a comma and include whatever variable is, something like that. Give it a value, right? Length is one of the variables that's there in your model, right? So I'm just going ahead and doing type equals response and getting the actual probability. This should actually be the probability. So I'll just print out the probability. Should be 0.35504. That is correct. Okay, so you see that the value is 0.35504, right? And then let me go ahead and do this. Let me calculate the log odds and remove the type equals response and do it my manual way. You'll see that the answer is same. It's again 0.3550. So there's a question of convenience. Or if the question asks for the log odds. Okay, so the next question is exactly that. He asks you for the log odds that a golfer sinks a 7 foot putt, for which you need to ignore type equals response and print log odds instead. That'd be it. Okay, yeah. So that's what I'm saying. If you think about it, log of p by 1 minus p is nothing but my log odds. By specifying type equals response inside your predict statement, I'm doing all this and we're getting this number, the p value. Okay. Okay. That is always an alternative. You put the summary of the model, write down the slope and everything, input the and then calculate all the way up to probability, or you can just use it. Okay. So that will be the log odds. Okay, and the next one. So so now you've trained your model. You want what? So you have 0.5 probability of 0.5, beyond which you say that your prediction is correct. So let's go ahead and do that. I'm importing the test data set in now. Test data equals read.csv. And I think I've already built the model, so I'll ignore that. So there are two ways of doing this, all right? You can use an if else statement, like I think your professor would have taught in class. Or there's another way of doing this. I have a marker, unfortunately. No. Okay. Okay, let me tell you how this works. Um, so on and is is above it's not given or so what I'm saying uh, uh, the value is zero, but as so what I'm as a variable good. Okay. Let me go ahead and print that for you so that you know what that looks like. So this gives me a table full of true and false values. Uh, and now that I know what these predictions for each of my data point and my test data are, what I'll do is I'll compare. This is what the actual values are, right? So so you can see the truth. So see what percentage of my predicted values are correct. All I need to do is sum all those values for which my summing them up and dividing them by the total number of rows on my test data. So that will give me the percentage of predictions that my model predicts right. Agreed? Yes. I defined it right here. Right? Oh yeah. Yeah. A testing. Yeah. Oh god, that's big. Yeah. Yeah, I have it. I'll probably do it at the end. Question. So both these versions would give you the same answer. I'll print them out for you. So it's 0.7033 using version 1 and 0.7033 using version 2. All right, let's move on to the next question. Um, what are the odds? That should be fairly straightforward. So we'll go to this one. It says that it's an output of the logistic regression model based on the election in 2016, solely based on how much a candidate's opponent spent in millions and whether they won or lost. And they're asking you what's the probability a candidate won if his or her opponent spent $12 million. So you have so right? So um, the log odds, right? That should give you the log odds, and from there you go ahead and calculate the probability. So it's the intercept. The log odds would be nothing but the intercept minus the slope times 12, storing it as an object called log odds. And now I'm calculating the exponential of log odds, and the probability would be nothing but odds by 1. So um, that should print the probability value for you, and the answer would be right. Let's go to the next question. Slope, if it's positive or negative, obviously just look at the sign um, of the coefficient before MCAT. That should tell you the slope is positive or not. Okay, let's go to question 13. It tells you, so it gives you an equation. Again, you just have to do it manually. Um, you find the log odds by inputting the intercept, slope, and an x value of 35. Print the odds by carrying out the exponential function, and then probability. And that should give you an answer of 0.4745. Questions? All right. I'll be skipping decision trees for now, but if you have questions at the end of the class, we can talk about decision trees. And maybe, yeah. Okay, so we'll just talk about these last two questions. You have a log model to your data. Um, give you given intercept, slope, and everything again. So he asks you what the value of y. Okay, give the answer. Uh, so substitute calculate log and then use the exponential function. Pretty straightforward. And this is how you do that. Um, remember that log So log in the natural logarithm. Okay. 21. Okay, so can adjusted R squared be used to compare, can adjusted R squared be used to compare models with transformation of predictor variables to models without? Okay, so when can't we use the adjusted? Sorry, obviously, but in the case of a simple, in case of a linear regression, when cannot I use adjusted R squared to compare to? Okay, so remember, but, but should be of the same scale. So you cannot use R squared. Or but as what transformation you this your response that because you change the of the word, right? Log y is different than y. So that's why it, I just think these kind of questions can be very confusing. Where we talk about theory, just think of it that way. Response variables, we can transform all day long. Response variables, we sorry. Can't do it also. Okay. Questions? Yes. Right. But you can you can transform y all day long, but you cannot compare a model where your response is y and your response is log of y and use the R squared to compare the models because the scale's been changed on the. That's right. It changes your R squared the way it's calculated. You just guessed. No. No. You look at the assumption. There's obviously other methods, but we have pseudo R. In other words, other fake. You can use your AICs and BICs. Right? Yeah. They have like information criterion, like yes, and still use adjusted R squared to compare. questions? Spend too much time on that question. Okay, we'll go to the next two questions. I think so it tells you that it gives you a regression statement where the constant. So, this variable because of this term, all right. So and and then would be nothing. So so that's it. So one and the other the one from the same term. So it would be minus 0.05 plus 0.88. So the slope would be point, which is around 0.83. And obviously, the next question asks you for the intercept, which is the same thing. Questions? Sure. I really wish I could write this down, but none of the markers are working. Okay, so this is what the equation looks like, right? Minus 1241 plus, what is that? 0.8872 times union, right? Plus, oh no, number of employees. Plus 5253 times union minus 0.05424 times interaction, or rather employees times union. Okay, so this is what that is. And I say so this is nothing but a would be 5 and then you're not but so this becomes minus 0.424 times and this is the so and that will be all right. Questions? Um, that's pretty similar to the practice method. So you're comfortable. I like that this practice method is more representative of the actual method. My personal opinion. Ranger, they're complaining. No. Ranger, you're giving them the wrong idea. Yeah? Yeah. That's what I mean.